All right, good morning, everyone. Thank you for the nice introduction. I'm Polygon, and I want to talk to you about low-cost, high-speed photography. So I started doing photography as kind of a hobby about 8 years ago. And after going through the usual phase of doing everything from, panoramas to macros, I kind of concentrated on studio photography, and being a student with limited room available, I kind of improvised a lot with what was there. And around at that time, I also watched a lot of YouTube and Vimeo videos, which were partially high-speed action. And I wanted to do this myself. And since I didn't have 20,000 euros to spend on a Phantom Flex high-speed camera, I started looking around to try to find out what I can do with my camera and the other equipment I already had. And so this talk is basically a mixture of a tutorial. So I did a lot of research on the internet. And so here is what the final result looked like, as well as like a slideshow. So to give you an idea, what this is all about, here is 2 pictures. So the first one, this is colored chalk being smashed by a mousetrap, and it gives this kind of exploding rainbow effect, if you will. And another example is this one. This is a water balloon right at the moment where it pops. So you can see in the lower right corner, the rubber skin is still partially intact, whereas on other places, the water's already basically splashing out. So just to formulate the requirements, this talk is about freezing some very fast action, and the action is fast in 2 senses. So the first thing, it just happens very fast. So you need a very, very short exposure time of roughly 1/50,000th to 1/10,000th of a second. And since these things look good only for, let's say, a couple of milliseconds, afterwards the water has splashed out a lot, so it's no longer interesting. You also need to time the exposure very precisely, so roughly with a precision of 1 millisecond is desired. Now, common digital cameras, they fail both of these requirements. So even if you look at high-end DSLRs, I think I've seen 1/8,000th of a second, but they cheat. So the way a camera shutter works in a DSLR, it has 2 curtains. So basically, when you start your exposure, the first curtain moves down, it exposes the sensor to the light, and at the end of the exposure, the second curtain moves down, blocking the light. Now, if you take a picture faster than roughly 1/500th of a second, they start moving the second curtain down before the first has opened. So it's basically a slit moving over the sensor. So every part gets 1/8000th second of light, but basically the top of the image will show you something earlier than the bottom of the image. So essentially, the camera will be taken completely out of this. And an alternative is flashers. Now, flashers, most commonly known in this form, so they have their flash bulb on top, then there is usually some kind of settings panel, and on the bottom there is the hot shoe where you slide it on the camera. So what can a flash do for us to help in taking these pictures? So let's go back to the very basics and compare a flash with an ordinary lamp. So if you have an ordinary lamp, it's basically characterized by giving off a certain amount of light per time. So the amount of light you capture in a frame basically depends on how long your shutter is open. That's, I guess, not a big surprise to anyone. Now, if you compare this with a flash is basically a capacitor and a flash bulb, and the capacitor is charged, and then it discharges over the flash bulb creating insane amount of power, several kilowatts, for a very short time, giving off this very fast pulse of light. So basically, as long as your shutter is open when the flash fires, you will always get the same result, no matter if you expose for like 1/10 of a second or 10 seconds. The only thing important is your shutter is open when the flash fires. And this is what I'm going to use to my advantage. So putting this together, if you take a picture in complete darkness, so the only light source is the flash, then the actual exposure you are going to get will be independent of whatever you set on your camera, and your effective exposure time of the image becomes equal to the flash burn time, so basically how long the flash is on. Now I searched Google to find the flash burn time for common flashes, and it turns out it's in your manual. So this is from my flash. It's a Nikon SB900. And so you can see that the flash duration or the burn time depends basically on the power setting. So if you fire the flash at full power, you will roughly gain 1/1000th of a second. And if you tune it down to the lowest power setting, you see a flash duration of roughly 1/40,000th of a second. And so that's pretty good. That's actually within the desired exposure times that I was aiming for. And what is also very nice, by changing the power settings, we actually have some control over the exposure. So that solves problem one, the very short exposure time that is required to basically freeze the image in place. Now, just to give you an idea of what a high power versus a low power flash actually looks like. So on the left, you see a picture taken with almost full power, and you see these small water droplets flying out, they become streaks. That is because the exposure lasts almost for a millisecond. So you get this very dynamic image, whereas on the right side, you see a picture taken with a very low power flash. So everything is really frozen in place, and it's basically, frozen the moment. So there is, of course, no absolute truths here. It depends on what picture you want to take, how you select your flash power, basically. So now, having solved this problem, I already told you that common digital cameras are too slow. They also have quite a long delay when you fire them of at least 100 milliseconds, which is much too long. So how can you trigger the flash without a camera? And the first way, it may sound ridiculous, but you can do it manually. So most flashes have a button on the back, and when you press the button, the flash will fire with whatever power setting you currently had. Now, of course, this is very inaccurate, but it's also very easy to do. And I actually took some pictures that way, which I'm going to show you later. But of course, at some point, you want to move to bring microcontrollers into the picture. So the most obvious way would be to interface with the flash hot shoe. So this is how a flash looks from below. On the left side, it's quite a new flash. It has 5 contacts for like digital communications, for measurements, for several signals. So modern flashes have lots of functionality, which we don't need. The right hot shoe basically shows a very old flash. It has just one contact, and this contact is called X-Sync for xenon sync, because xenon is what's in the bulb. And the only thing that I'm going to need is this X-Sync pin. And as you can see, if you compare the two pictures, it's also there on the left side. That's because there's an ISO standard for this, and it defines this pin. So all the flashes that were made in the last 25 years and have a hot shoe will probably work. So you have really a lot of flashes to shop for, which probably makes it quite cheap. Now, unfortunately, this hot shoe is very tedious to work with. So those contacts are basically spring contacts. They will slide back in when you push them. And so attaching something to it is quite tedious. So there's another method which is called PC sync. This was actually how you fired the flash before there was the hot shoe. So you basically had these cables that you see on the left with this weird connector there. And it's still being used in studio flashes and in also high-end on-camera flashes. However, the cheapest models, they only have the hot shoe. But luckily, you can get these adapters for like 10 euros, and they basically will convert your hot shoe to a PC sync cable. And you can get the cables with a standard headphone jack, which is very easy to use in microcontroller circuits. So how do you actually fire the flash? That's very easy. You connect the X-Sync to ground. So ground on the hot shoe is basically the metal layer outside, and on the PC sync, it's one of the signals carried with it. And when you do that, the flash will fire. So that brings me to the last question regarding flashes, and that is how accurately can you fire them, or what is the delay? So I didn't find a lot of information, so I decided to measure it myself. So you can see here basically a scope measurement of the sync signal shown in green starting on the top left. And the yellow signal is the response of a photodiode which was placed in front of the flash. And so you can see the green signal basically goes to ground, which triggers the flash to fire. And then in the second quarter of the picture, the photodiode response, and I don't know if you can see it, there is a time delay of 39 microseconds between these two events. So let's say roughly 100 microseconds, and I repeated this measurement probably 10 times, and it's very accurate. So the variation I've seen is within 2 microseconds, so basically negligible. So that solves problem 2. So apparently we can fire this flash in a fraction of a millisecond, which is very good. So how would you now go and connect your flash to a microcontroller? Basically, the circuitry is as simple as it gets. So you connect the X-Sync port to some random digital input of your microcontroller. You can use R1 as a current limiter, but to be honest, I didn't bother with it. It just worked. And there's two things to do correctly here, because otherwise I've seen very weird behavior from your flash. So the way this works is the X-Sync port from the flash, it carries a voltage of 3.3 or 5 volts, and it's basically being pulled up internally by the flash, and it senses when some external source pulls this pin low. So you do not want to drive X-Sync high from your microcontroller. So don't use any pull-up resistors, and even worse, don't configure the pin as output and pull it high. I've seen very strange behavior happening when I did this. And the second thing, when you pull the pin low, only do so for a short time, like 1 or 2 milliseconds, and then basically release it again. Otherwise, your flash will also start to behave strangely. Mine did, so it stopped firing for a while. You had to take out the batteries. Apparently, you can confuse them quite a lot by keeping the pin low for too long. Now, one very important thing to make sure is you should check the voltage that your flash gives you on the X-Sync pin. This is not standardized, so I've seen flashers with 3.3 and 5 volts, which is very convenient for microcontrollers. But I've also seen flashes with 12 or even 24 volts, where your microcontroller may actually be damaged. So in that case, you may need a little bit more an elaborated circuit, maybe use optocouplers to kind of completely separate the two circuits electronically. And if you have a very, very old flash, you should actually make sure that they don't basically put the actual flash circuit on there. So in the very first flashes, you basically had the 400 volts that is on the flash capacitor right on this pin. And so the camera would close the circuit. And really in a flash capacitor, there's enough energy to knock you out or even kill you. So if your flash is like 25 years old, please check that. Please don't die. It's not worth. All right. So just as a short recapitulation of what the flash does for us, it gives us a very short exposure time, roughly 1/40,000th of a second. It's super easy to control with a microcontroller, so you don't need to be an electronics expert. It has a very short firing delay of 100 microseconds, and it basically fires super accurately. So with that being out of the way, here's how you take a high-speed picture in 7 easy steps. So the first step is you build your setup. So kind of, I don't know, put up reflectors, put up a background, place whatever action you want to take a picture of. And when you're done that, you darken the room and you start a long-term exposure on your camera. Now this may sound a little bit counterintuitive for high-speed photography, but as I said earlier, since the room is dark, the exposure time on your camera doesn't matter at all, so you might as well make it a long-term exposure to kind of give you enough time to work with. Now, during this long-term exposure, you start your high-speed action. So I don't know, you fire your crossbow at an unfortunate apple or whatever. You have a microcontroller somewhere in there, and it will sense that the action has started. So maybe it is sensitive to sound. There may be a light barrier where something is flying through, or just some simple improvised switching going on. And after the microcontroller senses the action, it basically adds in a delay, and after the delay, it fires the flash. So then you wait for your camera to finish the exposure, and then you will, review your result, and most certainly, probably 99 of 100 cases, you will not be satisfied. So you improve your setup, and then you repeat it all again. Now there's 2 little points I didn't really talk about yet, and that is how to build a set, how to do this, and also how to let the microcontroller sense whatever action you are doing. And that is because, unfortunately, these 2 parts are very specific to what you are trying to do. So instead of giving you more theory, what I will do is I will explain 2 setups that I did. I will explain how I built the sets, how I made the microcontroller sense the action, to hopefully give you an idea that you then can build your own setups on. So let me start with the first one. This is about poking water balloons and taking pictures of how they pop. This is the setup. This is my bathroom back when I was living in a dormitory. And as you can see, it's quite tacked up. So there is the camera on a tripod. You can see all those cables around the toilet where the microcontroller is sitting. Yeah, it's probably not taking a dump, at least I hope. The camera is pointing to the shower where there is a black curtain. There is 2 basically gorilla pods combined into a Franken gorilla pod holding this scary looking device with a lot of duct tape. And you have a flash on another tripod with a self-made softbox. Now you notice the walls, they are white, which is very lucky. Otherwise you would want to put white fabric there. And the reason is photographic lighting. So the only light source there is basically the flash. And if you know these typical flash pictures, they have very hard shadows. And basically what you want to have is you want to have lots of reflection coming from the sides, from the top, from the bottom, just to give you a more smooth lighting. So that's why everything that is not the background should be as bright as possible and ideally white. However, before starting to take pictures with this pokey stick, I did some pictures manually because I took most of these pictures together with a friend. Chris, who unfortunately is ill for this Congress. And he was very skeptical about the whole idea. So he said, before I start programming microcontrollers, I want to know that this at least can work. So I said, okay, we try manually. And apparently he trusted the idea enough that he let me step a water balloon that he was holding in his hand with a knife in complete darkness while triggering the flash with my other hand. So I know it always takes a bit of magic out of the whole process, but just to give you an idea of what you can expect, this is how the picture came out of the camera. And a little bit of GIMP magic later, it's actually not a lot. You then end up with this. I've already shown it as an explanation example, but it's actually not a long way. It's a little bit of contrast, a little bit of sharpening, and you basically got this. So the second example would be this picture. I have also shown it in the beginning, but just that you see again how it comes out of camera and how close the knife was to his fingers. So, and again, the end result that you have already seen. So that were 2 lucky shots, and in between were a lot of shots that look like this. So if you do it manually, you will get lots of crap, basically. So you may fire the flash before, you may fire the flash way too late, but also you can see in the top right, this is basically not much too late when the flash fired, but you can see the water droplets, they already spread out all over the frame. The water itself has morphed to this strange mass. So really this process looks only good for the first few milliseconds, and afterwards, at least in my opinion, it becomes largely uninteresting. So let's finally bring microcontrollers in the picture. So this is the water balloon pop sensor in big. It's pretty simple, really. So basically there's a wire connected to the body using this screw there. And there is a second open wire very close to the pokey end of it. And the idea is the water balloon falls on there, the water creates a connection, and this is what tells our microcontroller now it's time to trigger the exposure. So here's a bit of the circuit. I turned it in a more famous symbol. So again, it's not rocket science. You have the sense, which is a digital input. It's being pulled with a pull-up resistor to 5 volts, and it connects to the open end. And actually, the ground contact does connect to the body of this quake sign. And so once the water drops in there, this little dashed circuit there closes, pulling the sense pin low, so the microcontroller sees a falling edge, the interrupt triggers, and the exposure starts. So that's really as simple as it gets. So here's a little bit of code. It's the actual interrupt service routine. I used an Arduino because it was there and it worked, so use whatever you want. I hope there is not a microcontroller that does not have 2 digital IOs and 1 interrupt, otherwise it probably sucks pretty hard. So there's basically 4 things going on here. The first thing is, of course, disabling the interrupts, very important. Then there is a delay loop, and the 2 lines in the middle, this is basically a debouncing. So in that case, if the signal was going high again while you were waiting, then the waiting loop would reset. I think for the water balloon shot, I actually commented this out because you want to trigger on the very first signal. For the mousetrap shots I'm going to show you later, you probably want to have this. So decide what works, try it out. Then here, the flash is fired. So not by writing low to the output, that was already there, but the port was previously configured as an input. So to the flash, it will look like a very high resistor towards ground, so basically like an open pin. And that's exactly what the flash wants to have. So it wants to drive its pin and not be bothered with it. And you only pull it to ground for like a very short time to trigger the flash. Then this part is another delay. It waits for roughly 2 milliseconds and then basically reconfigures the pin as an input, which tells the flash, get ready for the next shot. And then finally, the system goes disarmed and it also turns off an LED. And to start it again, you press reset. So there is not really a UI for now. If you want the code, it's on GitHub. It's really very simple. So if you want to improve on that, be my guest. So testing this out, this is one of the first pictures now using this poking device. And you can see it hits the moment quite well. And again, a little bit of GIMP magic later, you end up with this picture, which is actually one of my all-time favorites of the whole series. And you can actually remove this poking device quite easily. So I didn't spend 2 hours removing that. It was more like, 15 minutes. So now what you are going to see is basically you get the timing right after a little bit of tweaking every time. So now you can just go ahead, buy 100 water balloons, fill them up, and just go ahead, pop them every time. Because just because you get the timing right doesn't mean you will get good pictures. So there's still a lot of random stuff going on. Where the droplets are going, where the rubber is ending up, all of these is still random. So you still want to take basically a lot of pictures, but at least the timing is now right almost every time. So now you just keep going, take 40 pictures, 100 pictures, and then select the ones you like and post-process them. So here's the last one of my favorites because it reminds me of a sun eruption. So whatever you like. That's then basically a matter of taste. So coming to the second setup I want to show, this is about exploding chalk. I've also shown this in the very beginning. And the basic technique that this uses is mouse traps. So here's a mouse trap. Basically the way it works, it's one of those death traps actually. So it has this spring-loaded bar. It gets pulled over and is then held in place by this copper rod that you can see. And the copper rod slides under the triggering mechanism. So it keeps the bar from basically snapping over. And you would place the bait on the trigger and then the mouse goes there. It will move the bait. The rod will break free. The bar will snap and it will basically kill the mouse. Now, these are very good to give a very fast and forceful impact, so to kind of let high-speed stuff happen. But the triggering mechanism is not optimal. So basically, your zone where all your action is going on, what will be in your frame is to the right, right where the trigger is. So you have the trigger in the frame. You need to somehow maybe attach a thread to it to kind of trigger it from far away. And all of this stuff will be in your image, giving you big problems with post-processing. So what you want to do is you want to mod the mousetrap. And the solution that I ended up with looks like this. So you basically bend the rod into this S-like shape. So you can put it on top and it basically holds itself in place through mechanical counterforces. And basically you can slide this rod off to the top by maybe attaching a thread to this small hole on the top, and then it will basically break free and trigger the exposure. So now you have all the triggering mechanism out of frame. You can just remove it, and it's also a lot safer to start because you don't need your fingers or something else in the zone where this bar is going to go. Now I took a hit with a mousetrap. It's nothing that you whine very long about, but it's also not something you really want to have. So now here's the setup again. That's in my living room, and it's basically an improvised light tent built inside of a chair. So again, the background and everything which will be in the frame is in black. And all the walls and the ceiling is covered in white fabric. The reason is the same as before, to get lots of light to bounce back from all directions to the scene and give you a very even illumination. So you can see the microcontroller there on the left. There's lots of wiring going on, and you can see the trigger mechanism on the right. So there's this crocodile clip, the white one, which basically bites to the bar and is duct taped to the floor. So you want to have a lot of duct tape for this, by the way. And as soon as you release the mechanism, the crocodile clip will rip off, and this will tell the microcontroller to fire. So here is another wiring diagram. So I decided to put a 5-volt signal on the white crocodile clip, and the other clip connects to the sense input of the microcontroller. And while they are connected, it will read a high input, and as soon as it disconnects, the sense input will get pulled down to ground over R1, which results in a falling edge on the microcontroller pin, and that is what triggers the interrupt and allows you to fire the flash. So basically very similar to last time and not very complicated. Now before you smash chalk, which is a very messy business, especially if you decide to do it in your living room, I would advise you to start easy. So, well, we had some bottle caps ready for various reasons. So, you can put some drops of water in there and actually use this for, let's say, the first 50 shots, where you try to understand where are the variables in this process. So to make it more controlled, to get the timing right every time, it, especially in this case, took probably 100 pictures on its own, and you don't want to smash chalk 100 times. Not a good idea. So this works pretty well. It dries off quickly, and it's not really much cleaning work. And if you are lucky, you may even get quite a nice picture out of it, like this one. And so finally, you get your timing right. You put the chalk in, and well, this happens. So a mousetrap just doesn't cut it. So you can see it puts a little dent in there, and some small pieces fly off, but ultimately not too exciting. But as the old saying goes, when a mousetrap is not strong enough, you need a rat trap. So so this is basically scaled up. Everything else is the same. I did not take a hit to my fingers with this, but I wanted to see what it does to a metal edding. And after seeing what it did, unfortunately, I don't have a picture, but I'm fairly certain it will break your fingers. So please be careful if you try this. Then I decided to mod the trap again. So you can see the S-shaped rod again to kind of get the trigger away. I also decided to cover the front part in this black cardboard, which you will see later why. And you also want to strap this to something heavy. So this is a leftover piece from my kitchen countertop. So it's a really heavy piece of wood, because these things, well, they tend to take off when they fire. So maybe you have seen some of those slow motion pictures of mousetraps firing. Those things fly all over the place, and that is also what happens here. So attach them to something heavy. So obviously those things have enough power to obliterate chalk, basically. And here you can also see why I did these modifications to the trap. So if you don't, you get this bright wood in your frame, which really is very distracting for the eye. And you can also see the trap basically took off with the back that is out of the frame, which makes it very difficult to get the focus right and also to get the framing right of your picture. So if you attach it to something, you will again take a lot of randomness out of the whole process, and that's what you want to do. So now after improving the process, this is what you may get. So at some point, I started playing around with putting several small pieces of colored chalk together, and I really liked where this is going. So still improving the process. This is basically the final form, if you want. I don't know how many of these towers I built, but it takes probably 5 or 6 minutes. So you only want to bring these into play when you got your process down, because otherwise you will be doing nothing but super gluing chalk pieces together. So that's not so good. So yeah, then you just try if you got your process down. And at some point, you get this picture where everything is looking pretty good. And then you just have to take it to the GIMP. And finally, after a lot more post-processing, this is what I ended up with. Thank you. So yeah, exploding rainbows. So I hope that gave you an idea on how you can go about building a set, and also how to trigger the flash. So that basically ends the tutorial part. And now for the last couple of minutes, I want to talk a bit about the requirements of your gear to show you that if you are a little bit into photography, you probably already have everything that you are going to need. So let's talk about cameras. Your camera needs to be digital. So you really want to have this feedback, especially when calibrating your parameters. You don't want to wait a few days for your film to come back until you take the next change in, I don't know, your flash delay. So however, of course, since the camera is not doing anything except opening the shutter, you can of course put several cameras there, and one of them can as well be a film camera. So if you like film, you are not completely out of options. Now your camera needs to do a long-term exposure, so I recommend 5 seconds or more. This probably removes lots of mobile phones. I'm honestly not sure if there's phones that can take long-term exposures. I know mine cannot, but this is very practical to give you some time to start the action. I strongly recommend manual focusing, or at the very least, you should be able to set your camera that it's not focusing when you start the exposure, because you want to pre-focus, which you can do using the autofocus, but then you want to turn off the light and then you start the exposure, and if it tries to autofocus, it will probably completely get your focus wrong. But actually, I recommend manual focusing, especially in the last steps, because as you know, you have a basically depth of field. And so the objects that are in focus are in a certain range, basically starting a few centimeters away from your camera and ending a little bit more. And you can basically focus predictively. So maybe you want to make sure that the area of sharp objects is towards your camera, so that something that during the high-speed action starts flying towards your camera is still in focus. But that's like advanced stuff when you finally got the basics covered. And talking about stuff flying at your camera, you want to have a long lens. So I was using a 100mm lens because that's the longest I got and also the best. If you have more, I recommend more for 2 reasons. If your lens is longer, so you can be further away from your object and still get the same size. And having your expensive camera further away from Splashing water, or even worse, exploding chalk, is usually a good idea. And also, if you're using a telephoto lens, you basically have a narrower angle of view. And so basically, you will get less background into the picture. Whereas if you use a wide angle lens, you have a lot of background in your picture. And so you need to make all that background look good. Whereas with a tele lens, it's just a very small area. So it makes building your set a lot easier. All right. Let's talk about flash. As I said earlier, you can basically shop a wide area of flashes from the last 25 years. When the standardized hot shoe came into existence, there's a couple of flashes that use a proprietary hot shoe. You should make sure to get one with a standard one, so you can be sure that you have the X-Sync contact at the right place to use with the commonly available adapters. Otherwise, stuff may get a little bit more expensive. The flash needs to have an X-Sync port, and they all have. You can also go with studio flashes. Then you will already have the PC sync port, which makes the wiring a bit easier. And it has also shown to be very practical to shop for a flash that actually supports different power settings, because, as I said earlier, this allows you to set your effective exposure time. So there is some very cheap flashes. They don't have any controls except of an on-off switch. So you plug them on, they will always fire with full power, which is probably not optimal. You can start with that, but you will lose a lot of control over your process. So some other stuff that you may need, well, a microcontroller. So for example, an Arduino or whatever you have lying around. As I said, any microcontroller should have 2 digital IOs and at least 1 interrupt. Otherwise, it is hardly a microcontroller. Now, I recommend a tripod to put your camera on, maybe also a flash. So if you do like photography a little more seriously, you probably already have one. It doesn't need to be a fancy one, so you don't need to spend like €1,000 on a tripod. You can get a cheap one or even a used one, because the requirements are not very high. So especially for stability, as long as your camera isn't tipping over, it probably works, because 1/50,000th of a second, there won't be much movement in your tripod. Yeah, for the flash, you can get really creative. You can duct tape it to something. You can put it on these small Gorilla Pods or the Chinese copies of it, which also work pretty well. I recommend getting some black and white fabric, so you can use this sea adder fabric, Moltone, or something else. I have some fabric which is black on one side and white on the other, which kind of saves on fabric. I recommend having a stack of cardboard, also in the colors of black and white. They are super practical to build like light formers to block off light from areas where you don't want to have it. And yeah, go to any store that sells artist equipment. You can get them for like 10 cents a piece. So not very expensive. Some really, really entry-level electronics. So maybe a soldering iron, some tools, some pliers, and maybe a few resistors is really all you're going to need. You can also very easily use a breadboard for it. It's almost perfect. And duct tape, lots of duct tape. So that's the most important thing. So that is some final tips, which also is a little bit opinionated, but that's the things that I found that work best. So before putting up a very elaborated setup and smashing towers of chalk that require you like 10 minutes of building, first start with something easy to basically learn the process. So how your mousetrap snaps, the delays that you need to set. There will be a lot of misfires there. Really don't start too complicated, it will just slow you down and frustrate you. Once you got your process done, then please go crazy and make it perfect. So yes, you should expect a lot of failures when doing this. So you can probably expect 2 in a 100 pictures to be relatively decent, and you just need to keep going. So there's lots of randomness in this process, and if you want to get a good pictures out of it, you just need to sample by taking a lot of pictures and eventually being lucky and getting a good one. Now, what I also think is very important is to actually build your set to aid you in post-processing and also to prevent post-processing. So as I said, if you have this bright wood, for example, from the mousetrap in the pictures, not only does it look very bad, it also is very, very difficult to post-process because it's right where the action is. So removing this is virtually impossible, and it will give you a lot of work. Whereas if you cover it with black cardboard, it will basically start to vanish as soon as you turn up the contrast, and the black cardboard can even be used as a picture element, which is not distracting to the eyes, but just gives like a nice natural framing to the bottom part of the picture. You should make sure to clean and really prepare the set after every shot. So I actually used a vacuum cleaner to clean up the chalk set after every shot, because if you don't do this, then small pieces of chalk will be lying around everywhere, and the smash from the red trap is really, really strong. So all of these small particles will fly up and give you kind of a mist in your image, which destroys the cleanness. And finally, if there is some elements like the bars of the mousetrap that you cannot really mask and you cannot really prevent from getting in your image, then you should just embrace them. So make them part of the image and don't try to hide them like half-assedly, because that is never going to look good. So most important thing, of course, is to have fun and enjoy doing this. So here's some resources. Again, the code on GitHub, and some reads that I found interesting. So the first thing is Strobist. It started basically from this blog, Strobist, and it became a little bit of a movement in photography. So Strobist is basically people using flashes, sometimes lots of flashes, in a creative way to get good pictures. So there you can find lots of tutorials on how to use a flash to give you good photographic lighting. I learned a lot from them. You can actually look up high-speed photography tutorials. Seriously, put it like this on Google, you find tons of results. If you are more a friend of books, one very good read I had was the book Light, Science and Magic, which is basically a book about photographic lighting. So if you feel comfortable with your camera, I can heavily recommend it. I'm not associated with them, just to make that clear, but it's a really good read, and you learn a lot about how lighting works in context of photography. So if you want to contact me, there's my email address. This is my Flickr account, der Poli. I put lots of, or actually not so many, but all the pictures that I found worth showing over the years. So it's not just high-speed stuff, but also other studio pictures like the lamps that were there in the beginning. And since I used a lot of Creative Commons pictures for this presentation, I finally got around to change the license to Creative Commons. So if you want to use a picture, be my guest. So also for a little less complicated contact as compared to email, I created a Twitter account actually 2 days ago. So I will post a lot of these pictures over the next few days, and then, well, I see if I like it or not. So see where it goes from there. So that's basically the end of my talk. I would really love, if any one of you tries you, please contact me through any of this media and show me what you did. I like looking at cool pictures almost as much as I like taking them. And I do have some ideas for high-speed photography, which are not really suitable for a living room. So if you happen to live in Dresden and have a room where it doesn't matter if it gets a bit messier, I would really like you to contact me, and you may get a cool print out of it. So thank you for your attention and questions.
Okay, thank you, Polygon, for this very interesting talk. We still have quite a few minutes for questions. We have microphones in the room. You can line up behind the microphones. If you really have to leave the room, please be quiet. That means no talking. Thank you. And we're going to start with a question from the internet.
Okay, there has been some discussion about doing multiple photos, like a series. Do you think it is possible to do them with the movie mode and open shutter, or even using multiple cameras in a flash setup with multiple flashes?
So the first answer, we tried this using the movie mode and actually set the flash to kind of a strobe mode. So it basically fires 30 flashes a second, so my flash can do that. But unfortunately, even if you do the movie mode, the picture that is taken from the image, there is small breaks in between. So we never really got it to a point where the whole picture was illuminated by each flash. So basically you get lots of missing pictures or partial exposures, probably because the way the flash is read out by the camera. And on the other hand, 30 frames per second is not really much, so that is quite a lot of milliseconds between each frame. And so you probably have one frame, which is good, and the rest of the frames, which will be very boring. So I tried doing the movie and it didn't work, to put it simply.
And about multi-cameras and multi-flash, do you think there's a way to get that work?
If you want to use multiple flashes, you can try it. You should probably use flashes of the same build, probably ideally even of the same charge. So they have exactly the same firing delay. Then you can probably use several flashes. If you use flashes from different manufacturers, I tried this, and you will get double exposures. So you see there is basically two images. Now multiple cameras, no problem. You can point 10 cameras at it. As long as they are not in the way of each other, you can use as many of them as you want. So if any one of you has like 20 cameras to spare and wants to build a ring to kind of make a Matrix-style animation, it would be really cool.
Microphone one, please.
I have a remark about the flashes. If you use studio flashes, they have a quite long flash tube, and the flash duration, or Abbrennzeit in German, might then be a problem for high-speed photography. It's when you take pictures of your model and start throwing water or colorful powder on your model, and you want to have it flying, then you run into problems with cheap flashes. Let's say everything under 1,000 euros per flash is then a problem with a high-speed movement.
So if you use studio flashes?
Yes, if you use studio flashes. Small top-of-camera flashes generally don't have that problem.
Okay, very good to know. So don't use studio flashes, use on-camera flashes. Thank you. I didn't try them yet.
Microphone two, please.
On these cameras, there's like these wire shutters. Have you tried like firing the camera using the microchip?
Not yet, because it would be too inaccurate. So if you have a DSLR, they have to put up the mirror, they have to prepare the shot, like, I don't know, clear out the sensor, start the shutter. All of this takes probably several 10 of milliseconds of time. And since the trigger pulse only comes like really right before, you also need to have your exposure ready. This is generally be too long, so I didn't even try it. There is some tutorials on the internet for other scenarios. So let's say if you photograph a fountain, where it doesn't really matter when you take the picture, just that you freeze the action, then you can probably use this cable trigger. Yeah.
Okay, do we have another question from the internet?
Yes. Yeah, there was a question about what lens you were using and what f number, and did you have any problem with focusing?
So the lens I was using was a Tokina 100mm macro lens with I think it's an f2.8, but that doesn't really matter because you want to close your aperture. I think I closed it down to f16 or something, so right before you run into problems with basically diffraction because of a too small aperture. And yes, focusing is a huge problem because those objects are very small, so this is not very different from a macro shot. And since you don't really know where your stuff ends up during the high-speed action, it's a huge source of frustration when you get the perfect shot, but then your main part is slightly out of focus. So focusing, you will spend a lot of time on doing when you try this. And you will also have lots of failures because of focusing.
Microphone 3, please.
Hi. Thanks for the wonderful presentation.
Thank you.
How did you actually create the smoke inside light bulbs? Did you run a lot of current through the filament?
Yes. So maybe, as you can see it here, there is light coming out of the top. So the idea here is I used a kind of diamond tool like a dentist has to put two holes in the glass of the light, and then you blow in some oxygen to get out of the protective gas, and then you just attach it to a normal outlet, and yeah, that's going to happen.
Okay, thank you. I'll try it.
And microphone 1.
Hi, have you ever tried to shoot with a crossbow in a complete darkness?
No, I didn't, but if I try, I would probably put it on something that takes aiming out of the picture. And I wouldn't hold the apple with my hands.
Is there another question from the internet?
Yes, there is a question about the way you are triggering. You can either sense the moment the trap goes off and release the trap at a specific time for the mouse trap. Mm-hmm. So do you think there's any merit in timing the process rather than sensing when the trap releases?
I found it generally to work better if you actually get your interrupt before the actual action happens. So when the bar breaks loose, of course you should get your signal when it's already quite deterministic when the actual action will happen, so that you can configure the delay. There is some idea. So for example, when you're firing, let's say, a crossbow or a bullet at something, you can also put the mechanism behind it, maybe two aluminum foils which get smashed together by the impacting bullet. But then you're basically too late. So then you don't have control. You basically want to instantly, when the interrupt comes, you want to fire the flash. So you lose control. So I found it to work much better when I did have the information before. So I think I even tried to trigger on the bar smashing down on something, because obviously you can build a trigger there as well. But it didn't work that good, because you have this small 100 microsecond delay before the flash fires, and that can actually be too much. So I found it to work better getting to know before, finding out a good delay, and then firing the flash based on that.
Okay, we have time for one more short question. So microphone 2, please.
How do you complete darken the room?
Well, take the picture at night, cover the windows, and turn off the lights. So.
Okay, thank you once again, Polygon. Please give him a big round of applause.